Hello everyone, welcome to my channel. Myself Vasant, an undergraduate from mechanical engineering. We have already seen this. In order, the situation here demands us to resolve force into two components, that is Fu and Fv. Fu explains how much, or Fu state how much force this member has to sustain. Similarly, Fv indicates how much force this member has to sustain. So we can see in this planar case we have already discussed, we have easily forming the parallelogram or triangular law. With the simple trigonometry we can solve for this value with great ease. So the point is, whatever may be the direction, we resolve like this in a rectangular component for addition purpose. Similarly, whatever may be the direction, I can resolve and I can solve for a planar cases of force. But if the case is like this, you can see here a three-dimensional figure in which weld is made along specific direction. So let's take this green vector as a force acting on this component. So I need to find the component of force that acts perpendicular to the weld area which causes the breaking of weld. So you can see here in this 3D case we can't solve as we solved for the planar case just before. So we need some way to solve this kind of 3D problems. So that's what we are going to derive here. So let's take a planar case. Before solving for that, I like to introduce a most important vector manipulation, that is dot product of two vector, that helps us to solve this problem. So what a dot product defines? A dot product defines a vector dot b vector is equal to magnitude of a multiplied by magnitude of b into cos of theta, that is angle between them. So let's take a two Cartesian represented vector in two vectors that is represented in a Cartesian way. You can see here. So I am carrying out the dot product between this. So you can see I have to multiply I dot j, I dot k. I have to multiply all this. So let's separately multiply what an I dot I or j dot j and k dot k results. You can see here everything has magnitude 1 and the angle between them is 0. So that gives me with all these cases is equal to 1, because the cos of 0, the angle between I and I vector, j and j vector, k and k vector is unity, that is 0 degree. Similarly, all has unit magnitude. Similarly, if I take the crosswise I dot j, j dot k and k dot I, you can say here in all the cases we will get 0 as a dot product value, because angle between them will be 90 degree. That makes cos of 90 degree is equal to 0. With this I solve for this a dot b vector. So how can I solve? So first I multiply these two terms axi and bxi. You can see here I dot I gives me with the value of 1. Similarly, if I carry out other products like axi byj, so that gives me the 0. Similarly, if I take another product that is axi bzk, that gives me 0. So only possible value that comes as result here is ax and bx. Similarly, if I take the next case, that is ayj, only multiply with this gives me a value that is ay by, because j dot j gives me 1. Similarly, if I take the next last thing, so that gives me this value. So this is what the dot product is. So the result of a dot product is an scalar quantity. So it is called a scalar product. So if it is positive or negative, that defines along which direction the result is. We'll see it when we solve the problem. So I like to solve this problem. You can see in the first picture I represented a scalar form. A force vector is represented by its magnitude and its direction. You can see here f vector magnitude is root 2 and angle it makes with x-axis is 45 degree. Similarly, you can see another axis, we don't know about it, but it is indicated by letter A. It is from 15 degree from this f vector. So if I want to resolve f vector along this direction A, it simply I can take this value. So magnitude of f into cos of 15 degree gives me the value. If I want to find the perpendicular force, you can see here I resolve to find component along A and perpendicular to A. I calculate that completes this triangle, so I can state here this value is root 2 sine 15 degree. So this way I can solve, or from the given, for a given scalar form, I can solve or can resolve into two component forces. So what I actually do here, let's speak in formula format. So you can see here, to find the magnitude of component of F along A, I carry out this process, that is, first I take magnitude of F multiplied by cos of angle between them. So you can see this is what I am carrying out. So root 2 into cos 15 degree, that gives me with this value the magnitude of component of F along A. Similarly, so let's take the next case. You can see here the same problem as before, but it is represented in Cartesian form. That is, F vector is represented as a single vector format, not as a separate magnitude and direction. We are obvious that a vector is a combined form of representing direction plus magnitude. So the same information but given in a Cartesian form, F. Similarly, you can see here the direction of A in the previous case is defined by the angle 15 degree, but here it is defined by a unit vector. We have already discussed the unit vector will have a magnitude of 1. You can see here, if I solve for this, if I find the magnitude of this UA vector, that gives me the value of 1. So it only defines the direction of the A vector. So if this is the case, this is how the sum is given to us. How can I solve? That's what I'm going to deceive. That's what I'm going to solve, because in all the three-dimensional cases we are only given with the Cartesian form of representation. So you can see here, this is what I want to find, how I find. So you can see from the previous case, I have to do this to find magnitude of F along A direction. So how can I find this? We have just discussed the cross product gives the same result, that is F dot UA vector, that is unit vector along A direction, gives me this value. So let's check. Also, finding that magnitude multiplied by this UA cap, that is unit vector, gives me the FA vector. Similarly, if I want to find the vector that is perpendicular to A direction, you can see how can I solve for that. This is the triangle we have. We already discussed, if a triangular way of force is represented such way, this is the equation that defines this triangle. So F vector, actually we can state it in another way. F vector can be resolved along two components, perpendicular components, that is FA and that is F perpendicular. That's what I indicated here. So with this I solve for, knowing F vector is known. Similarly, I just found FA vector, so I can find F perpendicular vector. So from this, if I find the magnitude of F perpendicular, I can find the answer. So you can see here, it's time consuming, but we will have to check whether this is applicable or not. That is, this value we get should be obtained from this result. Similarly, this value we obtain should be obtained from this result. So let's check whether this is happening or not. So this is what two things we have to check. So from this I'm solving. First I find, that is magnitude of component of F along A direction. So first I solve for this dot product. So I'm carrying out this dot product. First I write F vector dot this UA vector, that is unit vector. So making this cross product, you can see here I come up with the result. So this result is same as what we expected. So this is acceptable. This way of solving is acceptable. Similarly, I have to find F perpendicular vector. So I'm solving for that. You can see here, first I find the FA vector by multiplying its magnitude and direction. That gives me the FA vector. So after solving for this FA vector, you can see here, I make the next step, that is to find F perpendicular vector. So I solve for this F perpendicular vector by first substituting F vector minus FA vector. So I come up with this F perpendicular vector. To find this magnitude, it's simple, we have already discussed. So this way I can find the the magnitude of this value f perpendicular. So let's see what the result we come up with. You can see here the same result as we needed. So this way you can see here how we can solve the same value in Cartesian form instead of scalar form. You can see here the scalar form is easy, but this Cartesian form is more time consuming. Why we have to prefer that? In 3-dimensional case, for example, we take the case here. This is a 3-dimensional case. There is a f vector represented in Cartesian form. It won't be represented in scalar form. It will be represented in a Cartesian form. So given here is the Cartesian way of representing f vector and the Cartesian way of representing the direction of UAB, that is unit vector along UAB. That's how we will be given with the data. We have already discussed how to represent f vector in Cartesian form and this unit vector in a separate videos. Make sure you do watch that before you see here. So with this I solve further what we have learned in this concept in this video. With that idea, I'm going to find, our motto is to find here FAB and f perpendicular. So with the concept we have learned in this video, I solve further. So knowing this too, it's obvious if we do this dot product, that gives me with magnitude of FAB. So if I want to find FAB vector, I have the magnitude value. So I take the magnitude value into normal multiplication of the direction of AB. So that gives me FAB vector. So further solving for f perpendicular, this substituting in this equation, all are known. So f vector is given in the problem. I have solved to find FAB with the help of dot product. So with that I find f perpendicular and I can solve for magnitude of f perpendicular. So you can see here the idea is in 3-dimension case can be only represented in Cartesian form. In Cartesian form, how can we find the value of components? That's what we have discussed in this video. Thank you for listening and make sure you do subscribe for my channel.